A square root is a 1/2 power. So another way of writing this problem is raising this to the 1/2 power. So when you want a derivative with respect to theta, the 1/2 can come down and multiply like the power rule says, and then get reduced by 1. So 1/2 minus 1 makes negative 1/2. But then we need to multiply that by the derivative of the innermost function. So just looking at this now, this derivative needs the product rule. A derivative of this first function with the second function kept the same, plus the first function kept the same times the derivative of the second function. The derivative of tangent theta is secant squared theta. Okay, and that's our derivative. How could we clean it up? I don't like negative exponents, so I usually put those in the denominator of a fraction, and so do textbooks. I think the motivation there is that you don't want to miss a divide by zero problem, because that causes asymptotes to happen where you have a divide by zero issue. And 1/2, it's the numerator times 1, the denominator times 2. So this is the same thing as what I have above. Right, I moved the negative 1/2 to a positive 1/2 by putting in the denominator, and a positive 1/2 is a square root. Can we clean this up is always the question. I think the answer is no. I think that's pretty good. Well, yes, you can. You can factor out a 2 from the numerator and the denominator, right? So factor out that 2, and that makes the 2 cancel out on bottom. There we go, a little cleaner.